Okay, so we're going to try this again. This is the second time that we are recording this video, and I just want to make sure that you guys have access to these notes before our next class together. So to start out for Blackboard assignment number 9, we're going to be talking about evaluating polynomials. And a way of evaluating these polynomials is recognizing if we even have a polynomial function. So today we're going to talk about deciding whether or not a function is a polynomial function, and if it is, we're going to talk about some key vocab words that are going to be important to locate or to identify of that function, and that's going to tie into our later discussions of their graphs. So at the start of your notes up at the top, it starts off with defining what a polynomial function is. And a polynomial function is a function of the form, I'm just going to kind of slide this paper down as we go, of f of x is equal to a sub n times x to the n power plus a sub n minus 1 times x to the n minus 1 plus, and then we have some space in between, plus, and then we can fill these in down the road with other terms, a sub 1 times x plus a sub 0. Are you going to have to know this general form? Absolutely not, but it's going to come into play in a couple of minutes. So I want to make sure that we had a chance to talk about that. With a polynomial function, a couple key things. The exponents, well, first off, a sub n, which is your leading coefficient that we're going to talk about in a little bit, a sub n can never equal 0. Your exponents are all whole numbers, and your coefficients, remember, coefficients are those numbers or values in front of your variables. The coefficients are all real numbers. Okay? So, for example, for this polynomial up here in the general form, polynomial a sub n, so this very first term, is called the leading coefficient, and a sub 0 is called your constant term. Okay? And n, which is your leading coefficient, that variable's exponent, okay, that n is called your degree. So moving forward, a polynomial function is in standard form if its terms are written in descending, so bigger to smaller, descending order of exponents from left to right. So standard form is going to be important to know. And that's when your terms are written in descending order from left to right. And we're already familiar with some types of polynomial functions. Okay, so these are going to look pretty familiar to you. The first is called a linear function. So in this example, your linear function f of x is equal to 3x plus 2 is called a polynomial function of degree 1. This is written in standard form because from left to right, we're in descending order of exponents. There's a little invisible 1 with our leading variable. So our degree is 1. Our leading coefficient in this example is 3. It's the coefficient that is with your highest exponent. And then the positive 2 is called our constant term. Another example that you're familiar with is the quadratic function. And in this example, we have f of x is equal to x squared plus 3x plus 2. This is also in standard form because we have our exponents in descending order from left to right, so bigger to smaller. This x also has an invisible 1 next to it. But because our highest exponent is 2, this is a polynomial function of degree 2. Our leading coefficient is always paired with our degree, so that number in front of x squared, there's that invisible 1. So we can call our leading coefficient 1 in this example. And the plus 2 is called our constant term. There's a chart given to you on this page that deals with the summary of common types of polynomial functions. And we're only going to talk about the top 4 today, or actually in detail during this unit. So starting off, degree 0 is called a constant. If you have a polynomial function of degree 0, we're going to classify this as a constant. Okay, we will call that a constant function. Okay, a constant. And its standard form is, as an example, f of x is equal to k. And an example of this would be f of x is equal to -5. In this case, we have no variable whatsoever, so we're going to call, and if you have no variable, we know that we have a constant function with degree 0. Our next degree is going to be 1. We're going to move up. If we have a degree 1, just like we did in this previous example, we know we have a linear function. One example of that would be f of x is equal to a times x plus b, where a is your leading term. That little invisible x, since you have an x there, your degree is going to be that one, that invisible one that's there. And the plus b in this case, that a sub 0 that we called it before, is going to be our constant term. So an example of this would be f of x is equal to 2x minus 1. And if you were given this type of example, you know because this x has an invisible 1, that's our highest exponent. Degree 1 would be considered a linear function. Moving on to degree 2 is called a quadratic, just like that example from before. A quadratic in standard form is f of x is equal to ax squared plus bx plus c. An example of a quadratic would be 3x squared plus 5x minus 7. I'm just making these up as I go, just giving you examples of what a quadratic could look like. This is in standard form because from left to right we're in descending order of our exponents. Our highest exponent is 2, so we know our degree is 2. With our exponent of 2, we have a leading coefficient of 3, and our constant term is negative 7. Moving on to degree 3, we have a cubic function. They're called cubics. An example of that would be f of x is equal to ax cubed plus bx squared plus cx plus d. An example of that would be f of x is equal to 7x cubed plus 2x minus 4. Notice in this example I don't have an x squared term, and that's okay. Because in order for it to be a cubic, your leading coefficient, or your leading degree, or your degree, has to be at 3. Okay? So it doesn't matter what anything else after that is, as long as you have this part, you know you have a cubic function. Last one we're going to talk about is degree 4. Those are called Cortex. Your Quadratic Functions in standard form, just following that standard form all the way through. Ax to the 4th plus bx cubed plus cx squared plus dx plus e. In this case, your e is your constant, your a is your leading coefficient, and 4 is your degree. An example of that would be f of x is equal to 9x to the 4th plus 2x squared minus 9, and that's okay if we don't have every single exponent represented, as long as your leading coefficient, or I'm sorry, your leading degree is 4. Moving on to example 1 on the back. All right, so in example 1, I provided for you guys the full out written explanation of what the example 1 is asking of you. Okay, so you guys have in front of you the entire written out explanation for numbers 1 and 2 for example 1. In example 1, they're asking you to decide whether the function is a polynomial function. If it is, they want you to write the function in standard form and state its degree, its type, and the leading coefficient. So in number 1, we have f of x is equal to 2x squared minus x to the negative 2 power. In this case, because you have an exponent that is negative, so it's not a positive whole number, we know that this is not a polynomial function. Okay? It is a whole number, but it's not positive. So if it's not positive, we do not have a polynomial function here. Moving on to number 2, we have f of x is equal to negative 4x to the 3rd plus x to the 4th minus 5. This is a polynomial function because your each of your exponents is a positive whole number, and each of your coefficients of each term are real numbers. So we have to go through and make sure we hit every piece of that direction. The first is we want to make sure we write our function in standard form. So because our highest exponent, that entire term, that x to the 4th, goes first, next in line would be the negative 4x to the 3rd, and then of course negative 5, which is your constant, goes next. Your degree in this case is 4, that's your highest exponent. Your leading coefficient is your coefficient of that degree. So in this case, it's going to be that invisible 1 that's out in front. So your leading coefficient is 1. I don't know why it was -4 there. -4 is not your leading coefficient. It's actually 1. And we will call this a quartic function. All right, so at this point, you guys have a handful of problems that are given to you. Then now you try, so I'm just going to highlight them and move forward. We'll go over these answers together the next time that we're in class. So let's move through to example 2. Actually, I have a sheet here that might be brand new example 2. Okay. So, one way to evaluate a polynomial function, so now we're getting into evaluating polynomial functions, is if you're given a value for x, all we're going to do is plug that value into your equation. So evaluating a polynomial basically means solving for f of x when x is equal to 3. So how do we write that? So one way that we can evaluate this is direct substitution. So since x is equal to 3, I know my function when x is equal to 3, I'm going to write that as f of 3, is equal to 2, and instead of x to the 4th, I'm going to plug 3 in for x, minus 8x squared, so I'm going to plug 3 in for x here, squared, plus 5, plug in 3 for this x, minus 7. From here, all I have to do is crunch each of those terms and then follow my order of operations. So my function when x is equal to 3, 3 to the 4th power times 2 gives me 162, minus 3 to the 2nd power is 9 times 8 gives me 72. 5 times 3 gives me a positive 15 minus 7. From left to right, my function when x is equal to 3 is equal to 98. So evaluating the polynomial is when you take that x value and you substitute it in and you solve for f of x. At this point, you have your now you tries. In your now you tries, you have 7 to 12. Oops. So at this point, f of sub 3 is equal to 98. I don't know if you guys were able to see that. I don't know if the video kind of chopped out for a second. But at this point, you have 7 through 12 that you guys can go through and evaluate. We'll make sure that we go over these answers the next time that we are in class. So the now you tries that were on the second page would dealt with numbers 3, 4, 5, and 6, as well as these last 6 problems are going to be homework for class the next time that we meet together.